Hello everyone. In the previous lectures, we covered unit number 1. This is the first lecture for unit 2. So in this lecture, we will study about the syllabus of unit 2. What is transistor, bipolar junction transistor, in short BJT, the classification of transistor like NPN transistor and PNP transistor. After, we will move on the working principle of the transistor. Next, the configuration of the transistor like common base, common emitter and common collector configuration. We will discuss these topics one by one. Next, we will move on the characteristics of the transistor, reason of operation of the transistor, and finally the reference of this presentation. So in this presentation, we will cover all these topics one by one. So let's start with topic 1. तो क्या क्या हमें यूनिट 2 में पढ़ना है वो हम देख लेते हैं पहले. तो यूनिट 2 में स्टडी करना है हमें ट्रांजिस्टर के बारे में. सो ट्रांजिस्टर BJT मींस बाइपोलर जंक्शन ट्रांजिस्टर, classification and configuration, working principle of the transistor, characteristics and the reason of operation. तो इतना पोर्शन हम अभी इस वाले प्रेजेंटेशन में कंप्लीट करेंगे. मींस ट्रांजिस्टर से लेके इसका रीजन ऑफ ऑपरेशन तक हम इस वाले प्रेजेंटेशन में जो है वो टॉपिक कंप्लीट करेंगे. आफ्टर दिस, लोड लाइन, बायसिंग मेथड, स्मॉल सिग्नल एनालिसिस ऑफ द ट्रांजिस्टर using H parameter, thermal runway and thermal stability, MOSFET, transistor as an amplifier, gain, bandwidth, frequency response. So one by one we covered all this topic and complete unit 2. Today's lecture we covered transistor, BJT, classification, configuration, working principle, characteristics and the reason of operation. Introduction of the transistor. Shockley J. Verdon and W. Breton invented the transistor in 1947. The terms transistor is derived from the word transfer and register. These words describe the operation of bipolar junction transistor, which is the transfer of an input signal from a low resistance circuit to a high resistance circuit. In this lecture, let us learn more about the bipolar junction transistor, in short BJT. So first question is, what is bipolar junction transistor? The bipolar junction transistor is a 3-terminal semiconductor device that consists of 2 PN junctions which are able to amplify or magnify a signal. It is a current control device. The 3 terminals of BJT are the base, collector and the emitter. तो बाइपोलर जंक्शन ट्रांजिस्टर होता क्या है? बाइपोलर हम इसलिए बोलते हैं क्योंकि बाय मतलब 2 होता है, तो इसमें 2 जंक्शन होते हैं, इसलिए हम इसको बाइपोलर जंक्शन ट्रांजिस्टर बोलते हैं. बाइपोलर जंक्शन ट्रांजिस्टर इज अ 3-terminal डिवाइस. इसमें 3 टर्मिनल होते हैं जिनका नाम है बेस, कलेक्टर और एमीटर. और बीजेटी जो होता है वो करंट कंट्रोल डिवाइस होता है. So BJT is a semiconductor device which is constructed with 3 doped semiconductor region, that is base, collector and emitter, separated by 2 PN junction. A signal of small amplitude applied to the base is available in the amplified form at the collector of the transistor. This is the amplification provided by the BJT. Note that it does not require an external source of DC power supply to carry out the amplification process. The word transistor is derived from the word transfer and register. अभी हमने देखा कि जो ट्रांजिस्टर बना हुआ है वो दो टर्म से मिला के बना हुआ है, ट्रांसफर और रजिस्टर. The transfer of an input signal from a low resistance circuit to a high resistance circuit. तो ट्रांसफर का मेन फंक्शन क्या है? सिग्नल को ट्रांसमिट करना है लो रेजिस्टेंस से हाई रेजिस्टेंस सर्किट को. This is the diagram for transistor, NPN ट्रांजिस्टर. तो दो n रीजन के बीच में एक पी को सैंडविच के फॉर्म में जब हम बनाते हैं तो इससे NPN ट्रांजिस्टर बनता है. इसके टर्मिनल के नाम आप देख सकते हैं. एमीटर रिप्रेजेंटेड बाय कैपिटल E, कलेक्टर रिप्रेजेंटेड बाय कैपिटल C, and base is represented by capital B. So in this diagram we clearly seen there is the two junction. So this is called the bipolar junction transistor. The junction name is emitter based junction and second one is collector based junction. The transistors are used in the construction of ICs, means integrated circuit. The number of transistors that we have been able to fit into an IC has rapidly increased since their creation, doubling approximately every 2 years, known as Moore's law. Now, why this is called the junction transistor? The answer lies behind the construction. We already know that what is p-type and n-type semiconductor. Now, in this type of the transistor, any one of the type of semiconductor is sandwiched between the other type of the semiconductor. For example, an n-type can be sandwiched between the two p-type semiconductor, or similarly, one p-type can be sandwiched between two n-type semiconductor. These are called PNP transistor and NPN transistor respectively. We will discuss about them later. Now, as there are two junctions of different type of semiconductors, this is called the junction transistor. It's called bipolar because the conduction takes place due to both electrons as well as the holes. The next topic is a classification of transistor. So, bipolar junction transistor are classified into two categories. First one is called PNP, another is called the NPN transistor. Basically, the bipolar junction transistor are classified based on its contact, whether it is the point contact or the junction. But the transistors with the junctions are most commonly used these days. These bipolar junction transistors are formed due to the combination of semiconductor diode is classified based on p-type and n-type connected. So BJT can be classified as NPN transistor and PNP transistor. This is the symbolic representation of PNP and NPN transistor. सिंबॉलिक रिप्रेजेंटेशन में सबसे इंपॉर्टेंट होता है द डायरेक्शन ऑफ करंट. एरो जो डायरेक्शन हम बनाएंगे वो ही हमारे डिफाइन करता है कि एनपीएन ट्रांजिस्टर है या पीएनपी ट्रांजिस्टर है. दिस इज द वर्किंग डायग्राम ऑफ पीएनपी एंड एनपीएन ट्रांजिस्टर. देयर इज 3 टर्मिनल, एमीटर, बेस एंड कलेक्टर. ट्रांजिस्टर में सबसे इंपॉर्टेंट पार्ट है जो उसका बेस होता है वो बहुत ही थिन होना चाहिए. Now first one is a PNP junction transistor. PNP bipolar junction transistor, a n-type semiconductor is sandwiched between two p-type semiconductors. The diagram of PNP transistor is so below. In this diagram, there is three current. IE is called emitter current, IB is called the base current, and IC is called the collector current. And two voltage, VEB means voltage across emitter to base, and VCB means voltage across collector and base. In the PNP transistor, the emitter is more positive with the base and also with respect to the collector. The PNP transistor is a three-terminal device that is made from the semiconductor material. The three terminals are collector, base, and emitter. And the transistor is used for switching and amplifying application. The operation of PNP transistor is generally the collector terminal is connected to the positive and the emitter to a negative supply with a resistor, either the emitter or the collector circuit. To the base terminal, the voltage is applied and it operates transistor as an on/off state. The transistor is in the off state when the base voltage is the same as the emitter voltage. The transistor made its on state when the base voltage decreases with respect to the emitter. By using this property, the transistor can act on both applications like switch and amplifier. The basic diagram of PNP transistor is so below. So this is the diagram for PNP transistor. First one is the practical diagram, or second one is the symbolic diagram of PNP transistor. Second is NPN transistor. The NPN transistor is exactly opposite to the PNP transistor. The NPN transistor contains three terminals which are the same as PNP transistor, which are emitter, collector, and base. The operation of NPN transistor is generally the positive supply is given to the collector terminal and the negative supply to the emitter terminal with a resistor, either the emitter or collector or emitter circuit. To the base terminal, the voltage is applied and it operates as an on/off state of a transistor. The transistor is in off state when the base voltage is same as a emitter voltage. If the base voltage is increased with respect to the emitter, then the transistor made its on state. By using this condition, the transistor can act like both applications, which are amplifier and switch. This is the diagram for NPN transistor. The next topic is working principle of BJT. Bipolar junction transistor, in short, in BJT. The base emitter junction is forward bias and the collector base is a reverse bias. So in a figure, the width of the depletion region of the common base junction is higher than the base emitter junction. The forward bias at the base emitter junction decrease the barrier potential and produce electrons to flow from the emitter to the base, and the base is thin and lightly doped. It has very few holes and less amount of the electrons from the emitter, about 2%. It recombines in the base region with holes, and from the base terminal it will flow out. This initiates the base current flow due to the combination of electrons and holes. The leftover large number of electrons will pass the reverse bias collector junction to initiate the collector current. By using KCL, we can observe the mathematical equation. Emitter current IE is equal to base current plus collector current. The base current is very less as compared to the emitter and collector current. So we can say that the emitter current is approximately equal to the collector current. Means IE is approximately equal to the IC. Here the operation of PNP transistor is the same as the NPN transistor. The only difference is only holes instead of electrons. The below diagram show the PNP transistor of active mode region. Next is the equivalent circuit of BJT. A PN junction is represented by a diode. As a transistor has two PN junctions, it is equivalent to two diodes connected back to back. This is called as the two diode analogy of the BJT. So this is the equivalent circuit of BJT, or we can say that PNP transistor equivalent circuit. Here the circuit of BJT can be represented by the two diodes with the junction PN. This represents the equivalent circuit of BJT. Next topic is a configuration of BJT. BJT can be connected in three different configurations. By keeping one terminal common and using the other terminals for input and outputs. These three types of configurations respond differently to the input signal applied to the circuit because of the static characteristics of the BJT. Three different configurations of BJT are common base, in short CB, common emitter, in short CE, common collector, in short CC configuration. Among these, the common base configurations will have voltage gain but no current gain, whereas the common collector configuration has current gain but no voltage gain, and the common emitter configuration will have both current as well as the voltage gain. So first one is common base configuration. The common base configuration is also called as the grounded base configuration, where the base of the BJT is connected as a common between both the input and output signals. The input to the BJT is applied across the base and emitter terminals, and the output from the BJT is obtained across the base and collector terminal. So this is the diagram for common base configurations. इस डायग्राम में हम देख सकते हैं जो बेस है वो दोनों ही साइड मींस एमीटर और बेस सर्किट और बेस और कलेक्टर सर्किट दोनों में ही जो बेस है वो कॉमन है. सो दिस डायग्राम इज नोन एज द कॉमन बेस कॉन्फ़िगरेशन. The input current IE flowing through the emitter will be quite higher when compared with both the base current and the collector current, as the emitter current is the sum of both the base current and collector current. Since the collector current output is less than the emitter current input, the current gain of the configuration will be unity or less. Next is the common emitter configuration. The common emitter configuration is also called the grounded emitter configuration, where the emitter acts as the common terminal between the input applied between the base and emitter and the output obtained between the collector and the emitter. So this is the diagram for common emitter circuit. इसमें हम क्या करते हैं, इसमें emitter को है जो वो common करते हैं. So this is called the common emitter configuration. This configuration produces the highest current and the power gain when compared with the other two types of the configurations. This is because of the fact that the input impedance is low as it is connected to a forward bias PN junction, whereas the output impedance is high as it is obtained for the reverse bias PN junction. Third one is common collector configuration. The common collector configuration is also called the grounded collector configuration, where the collector terminal is kept as the common terminal between the input signal applied across the base and the emitter and the output signal obtained across the collector and the emitter. This is the circuit diagram for common collector configuration of the transistor. This configuration is commonly called as voltage followers or emitter follower circuit. These configurations will be useful for impedance matching application as it is very high input impedance in the region of hundreds of thousands of ohms while having relatively low output impedance. The next topic is characteristics of BJT in a different configuration. First is common base configuration. हमने देखा अभी common base configuration क्या होता है. इसमें जो ट्रांजिस्टर का बेस होता है उसको हम कॉमन रखते हैं, सो कॉल्ड एज अ कॉमन बेस कॉन्फ़िगरेशन. सो हर बेस में दो कैरेक्टरिस्टिक्स होती हैं, इनपुट कैरेक्टरिस्टिक्स एज वेल एज द आउटपुट कैरेक्टरिस्टिक्स. तो हम तीनों बाइसिंग में जो हमारा कॉमन बेस, कॉमन एमीटर, कॉमन कलेक्टर, ये तीनों बाइसिंग है, इसमें हमने तीनों में अलग अलग इनपुट और आउटपुट कैरेक्टरिस्टिक देखेंगे. तो फर्स्टली हम देखते हैं कॉमन बेस कॉन्फ़िगरेशन इनपुट कैरेक्टरिस्टिक्स. So this is the input characteristics for common base configuration of transistor. The input characteristics curve for the common base configuration is drawn between the emitter current IE and the voltage between the base and emitter, means VEB. During the common base configurations, the transistor gets forward biased, hence it will show characteristics similar to that of the forward characteristics of a PN junction diode, where the IE means emitter current increase for fixed VEB means emitter base voltage when VCB increase. तो इसका जो कैरेक्टरिस्टिक्स बनेगा सेम टू सेम वो डायोड का जो फॉरवर्ड बायस में कैरेक्टरिस्टिक्स बनता है सेम वैसे ही बनेगा. तो ये हमारा हो गया इनपुट कैरेक्टरिस्टिक्स. कैरेक्टरिस्टिक ड्रॉ होता है हमारा एमीटर करंट और VEB के बीच में. तो VCB की डिफरेंट वैल्यू हमने ली है, 0 वोल्ट, -10 -20 वोल्ट. VCB इज कॉल्ड द वोल्टेज अक्रॉस कलेक्टर एंड बेस टर्मिनल. Next is the output characteristics. So this is the output characteristics of The common base configurations are given between the collector current IC and the voltage between the collector and the base. Here the emitter current IE is the measuring parameters. Based on the operation, there are three different regions in the curve. At first, the active region. Here the BJT will be operating normally. An emitter junction is reverse biased. Next come the saturation region, where both emitter and collector junction are forward biased. Finally, the cut-off region, whereas both emitter and the collector junctions are reverse biased. तो आउटपुट कैरेक्टरिस्टिक्स थोड़ी डिफरेंट होती है पीएन जंक्शन डायोड से. इसमें हमारे पास तीन रीजन होते हैं. तीनों रीजन जो है वो कैरेक्टरिस्टिक्स में शो हो रहे हैं. Saturation region, cut-off region, and active region. Now the next is a common emitter configuration characteristics. Input characteristics. The input characteristics of common emitter configurations are drawn between the base current IB and the voltage between the base and emitter, VBE. Here the voltage between the collector and the emitter is the most common parameter. If you could see, there will not be much difference between the characteristics curve of the previous configuration except for change in the parameter. Output characteristics. The output characteristics are drawn between the collector current IC and the voltage between the collector and the emitter VCE. The VCE configuration also has the three different regions: active region, saturation region, and cutoff region. In active region, the collector junction is reverse biased and the emitter junction is forward biased. In the cutoff region, the emitter junction is slightly reverse biased and the collector junction is not completely cut off. And finally, in the saturation region, both the collector and the emitter junction are forward biased. The next topic is region of operation. The biasing of bipolar junction transistor is nothing but the application of the external supply of the voltage to the respective junction involved in it. This biasing leads to the major process of the transistor based on which the regions are classified. So the first region is cut-off region. As both the junction of the transistors are not supplied with any external supply, hence there is no evident supply of the voltage seen, the region formed is defined as the cut-off region. The second one is called the active region. In this, the one junction must be kept in the mode of forwarding bias and the other will be at the reverse bias. This type of the region is referred to as active region. In this, the Q point will be at the center of the characteristics curve so that it is most frequently used during the operation. Third one is called the saturation region. In this, both the junctions must be at forward mode, that is on highly conducting mode. This type of the region is referred to as the saturation region. During the application of the transistor as a switch, the cutoff mode and the saturation mode are preferred. That is, either it should function in completely on mode or off mode. Has this Q point concept in the active region and in the other modes. In order to make it stable, there is the requirement of the biasing. So biasing number one is fixed bias. This bias is also referred to as the base bias. In this type of the bias, the connection of the single power supply will be maintained between the base and the collector with the help of two resistors. If the value of the resistors or resistance are varied, based on it, the current at the terminal base can be adjusted. In this way, the Q point can also be monitored. Second is collector base bias. In this, the resistor of the base is collected across the collector rather than connecting it to the supply. This type of the bias is preferred during the stabilization of the Q point against the temperature change. If the collector current tends to increase, there can be the voltage drop at the resistor, resulting in the reduction of the value of the voltage across the resistor of the base. In this way, the current at the base get reduced simultaneously. The current value at the collector is reduced. This will reduce the effect of the temperature on the Q point by making it stable. Number 3 is self-bias. This type of bias is also referred to as the voltage divider bias. This type of bias is the most frequently used. The resistors arranged in the form of potential divider circuitry. Hence, the equal or the fixed amounts of the voltage are supplied to the base terminal. In this way, the biasing techniques for the transistor are classified. The next topic is application of BJT. So the application of bipolar junction transistor are as following. Number 1, these are the transistors that are preferred in the logic circuits. Number 2, it is used in the circuit of amplification. Number 3, these are preferred in the oscillation circuits. Next, these are preferred in the multi-vibrator circuits. In the clipping circuit, these are preferred for wave shaping circuit also. It is used in the circuits of timer and the circuits of the time delay. Number 7, these are used in the circuits of switching and also used in the circuits of detector or as demodulation. So these are the application of BJT. And finally, the reference of this presentation. So these are the references. And thank you for watching this video.